Okay, understanding the nervous system. The nervous system is the connection between the brain and the body. It's how we know to regulate our body with what's going on in the external environment and the internal environment. So, the autonomic nervous system is automatic. It's the kinds of things that go on without us having to think about them, like breathing or your heart rate or digestion. There are some different states of the autonomic nervous system. The parasympathetic or calm state. In this state, the nervous system is regulated and feels safe. It's relaxed, connected, and creative. You may hear it called the ventral vagal state. So that's what happens when you're feeling good, you're feeling safe. But if your brain and nervous system detects some danger, you may go into the sympathetic state. That's fight or flight. It's a high arousal state because, again, your brain or your nervous system sense that there may be danger. You may be on guard, tense, fearful, or agitated. And then if your brain and nervous system think that the threat might be more than you could handle, so you couldn't fight or flight, then the option is to go into freeze or fawn, where you basically conserve your energy by shutting down. In this state, you may feel hopeless, lethargic, or lack of energy, or dissociated, just completely disconnected from your body. So the vagus nerve is what controls the autonomic nervous system. You see its picture here on the left and all of the different organs and body systems that it innervates. And an interesting thing about the vagus nerve is that up to 80% of the nerve fibers are afferent, meaning coming from the body and going to provide information to the brain. So the vagus nerve controls your heart rate, your blood pressure, your immune system, inflammation in your body, satiation, so whether you're feeling full or not, your stomach acidity, blood sugar regulation, bile release and production, water and sodium balance, saliva, sweat, and tear production, your focus, your mental focus, or the feeling of fatigue in your body, and your voice. The vagus nerve even controls the melodic quality of your voice when your nervous system is regulated. So an important thing to remember here is that when we're thinking about our nervous system adapting to the environment externally and internally, we don't necessarily need our nervous system to be constantly regulated at a single point. We want our nervous system to be flexible, adaptable, and regulated in that when it goes to too high of stress or into the freeze response, we get back to this state of calm. They call that the window of tolerance. But you know that you won't be calm all of the time, and that's normal. That's part of the normal human experience. So if you think of this area that we're more regulated, where we can handle things, we feel safe, that parasympathetic state, that's our window of tolerance. And that can change depending on internally at that subconscious level, how safe we feel. So our nervous system is constantly scanning for danger and reacting in ways so that we'll survive. So if you look at this example below, you see the window of tolerance, and the person's nervous system state is represented by the line that goes up and down. So say you get an email from your boss that your boss wants to talk to you. You don't know what it's about, and so you start to feel a little nervous. You see the line going up. It's going out of the window of tolerance. You may be in fight or flight. You may be feeling defensive or scared, wanting to run away, wanting to avoid it, wanting to argue with your boss in your head. Then you meet with your boss. She validates your work. You're actually given an extra assignment because you've been doing so well. So then you start to feel regulated again. You start to feel better. You're not scared. You're not thinking you're going to lose your job or all of the other things that your brain spun out on and went to when you didn't know what to anticipate and you felt unsafe. You kind of go back to that window of tolerance down here. And then you may start that project that the boss gave you, and you get into overwhelm. it seems like more than you can handle. I can't do this. And you go into freeze mode. So you may find yourself avoiding that activity, totally doing something different, procrastinating. And then when it's time to go home, all of a sudden you start feeling a little better. You're mobilizing, you're moving, you're doing something, you get back to your window of tolerance. And then, this is hypothetical, but say the kids are yelling at home, whatever, you go home and there's something that's a little more triggering or, kind of gets your nervous system ramped up. And then you may go into fight or flight again because of that. Now, again, the main thing isn't that we are, always in the window of tolerance and that's our 100% goal. Our main goal is to recognize when we're in these states of nervous system arousal and to bring ourselves back down with compassion, because that's the way that will work the best to get back to our window of tolerance. And we have that compassion by understanding what's going on. So this window of tolerance, the parasympathetic state of calm, the ventral vagal, is where we feel open and safe and regulated. And it actually takes less energy to deal with outside stressors. You might notice, for example, when you're feeling really good, maybe something great happened to you and you're driving around and someone cuts you off and it really doesn't even bother you. Where you're out of your window of tolerance, any little thing could contribute and could start to add up to this great expenditure of energy just to kind of get through your day and maintain. The window of tolerance is also where you can best use your prefrontal cortex. So this is the thinking brain. This is where we can rationalize. And so it's nice to know that when you feel dysregulated and you've been beating yourself up because the thought work isn't working and you can't figure out why you can't just think different thoughts, this nervous system approach is going to help you understand that when you are in your window of tolerance, that's when you can do the thought work the most efficiently, right? That's where you'll really be open and receptive to things that make meaningful change. But if you've been living more on the extremes of these dysregulated states, then trying to do thought work from that place is, again, going to be a little more energy taxing and not quite as easy. So as we practice noticing these nervous system states and bringing ourselves back to where we're calm in this window of tolerance, the window of tolerance actually grows. And as it grows, we're able to tolerate more. We become less and less reactive to the external environment and become more regulated within ourselves. And as you learn how to practice regulating your nervous system, you have less anxiety about going to those nervous system states that feel uncomfortable, like being in fear or being in freeze. You start to see it as something that's normal, that happens, and that every time in your life so far you've been able to handle, and you can handle this time too. All right, so key takeaways. The vagus nerve is the main communication between the body and the brain. Another picture of it here. See how it innervates all of those organs, and 80% of the fibers, again, are coming from the body and going up, giving information to the brain. It controls whether you're in the sympathetic fight or flight or the parasympathetic, and which state you're in is determined by your perception of safety or danger. This is an important point because it has to do with our perception. We may not feel like we're in danger in a place that we are, right? We might be swimming in an ocean and not know that there's a shark. Oh, that's a horrible example. I'm afraid of sharks. But to prove a point, you may be someplace that's dangerous and not even know it. Or you may perceive danger in a place where you're actually safe. But the nervous system responds to the past and the meaning that the brain has made, the coping strategies it has, and it will respond automatically in these ways that will start to indicate to you, something about me is not feeling safe right now. So moving between the states is healthy. That's what we want. We want to even move out of the window of tolerance. That's normal. But getting stuck in the extremes is what we want to avoid. Okay, so I want to go over this slide with you There's a lot here. This was a summary that I found by Lisa Rankin and the references there. And I like the way that it's presented and put together. You'll see the bottom is the window of tolerance we were talking about, the ventral vagal. And that's the area of social engagement. There's joy, you're present, you're grounded, connection, safety, you're oriented to the environment, you're curious and open, compassionate, and mindful. So all of those are in this ventral vagal state. It's also called the parasympathetic nervous system. This is the rest and digest state where you are better able to process your food. You're more resistant to infection. It increases your immune response. You're better able to rest and recuperate, better circulation to your skin and extremities, increased oxytocin, which is a neurotransmitter of social connection. You can even have an increased ability to relate and connect. There's a decrease of the defensive response. As pictured here, you see the sympathetic and the dorsal vagal compared to the arousal. The amount of arousal is on the left side as arousal increases. So that's arousal of the nervous system. And connection decreases as you go up the chart. Then you get to the fight or flight, and then you get to that dorsal vagal, which is the freeze state. So in the sympathetic state, it's where you detect a mild threat, something that you either want to fight or run away from to survive. Fight is like a movement towards, so there'd be rage, anger, irritation, frustration. Flight is a movement away, so panic, fear, anxiety, and worry. With the sympathetic nervous system, there's an increase in blood pressure and heart rate. There's an increase in fuel ability, an increase in adrenaline, and an increase in circulation to the vital organs and blood clotting, as well as pupil size. If you think about your eyes taking in more information so that you can get away from the threat and survive. It decreases things like digestion and salivation, your relational ability. So that connection with people is decreased in this state. And as well, your immune response. And then the dorsal vagal state is a higher threat, a perceived mortal danger, even that it's not safe to try to fight, or you're not going to survive if you flee. So the best strategy for you is to freeze or fawn, to totally start to collapse and shut down. You may feel immobile, helpless. You conserve your energy. This is the area of depression. You might feel numbness in your body or dissociation. This is where shame comes in. There's shutdown. There's a hopeless feeling. It's a preparation for death and a trapped feeling. It's an emergency state where your heart rate and blood pressure decrease, your temperature decreases, your muscle tone can decrease, less facial expressions, less eye contact. Those intonations of the voice that are controlled by the vagus nerve are not there. The awareness of the human voice is decreased. Social and sexual behavior is decreased, and as well, the immune response. Now, I've already said this, and I'll say this a lot of times, but we're not trying to live our life in order to avoid trying to get into any of these aroused nervous system states. It's normal to have fight or flight. It's normal to have freeze and fawn. Brene Brown's research is focused on shame, and she says shame is a normal human emotion to have unless you're a psychopath. The primitive brain might want to try to control all the circumstances to avoid ever getting into these states that are uncomfortable. But what you can start to learn is that you can tolerate and identify being in these states and learn strategies to bring the nervous system back into regulation. So no matter where you are now, you can develop a nervous system that's healthy and resilient. Good vagal nerve tone, which means it's flexible, it's responsive. More effective responses to sensory input, so not under responding and ignoring or over responding and exaggerating or catastrophizing. You can develop confidence that you will be able to adapt to your internal and to your external environment. Now, I put this here so that you could imagine the parts of the brain that we have in context. The lower part of the brain, the reptilian brain, if you look actually at the more primitive species of animals, the reptiles, they just have this lower part of the brain. They're still living. The brain takes care of these autonomic functions, such as sensation, arousal and regulation, which is homeostasis, and initiation of movement and impulses. It's kind of like instinctual behavior that is programmed into this part of the brain. And then there's a mammalian brain. This is the limbic system. It's the level of feelings and emotions, interaction and relationships. And so you'll see more of the mammal species have, different degrees of developed brains of the limbic system. And we have that too. It makes up our subconscious. The limbic system and the reptilian brain are more for those habitual programs the brain runs for the body to be able to run on its own, maintaining this homeostasis, regulating your temperature, your breathing, your digestion, all of these things that you're not thinking about because you couldn't possibly think about all the things and control all of the things that your body is doing subconsciously. The outer brain in the blue is the primate level. That's where thinking and consciousness occurs. That's where you can have memory, where you can use abstract symbols, planning, and inhibition of impulses. So I point this out here because, again, when we're thinking of the nervous system and brain interaction, it's mainly more at the reptilian brain level and the mammalian brain level. We're really not getting into too much of the prefrontal cortex or the primate level where our clear thinking is happening, where we're thinking with our highest functioning brain. And that is normal because our brain primarily is concerned with survival. So if there is a perceived threat in the environment, our brain would much rather prepare our body for this threat and for danger and put us into one of these nervous system states rather than remaining where we could be potentially in harm's way. So basically, our brain and nervous system are just continually trying to assess and determine if we are safe or not. And an important thing to remember is that our nervous system was formed when we were a child. So it is based in our past. I like this picture here because I think as a child, I do remember sometimes that I think seemed particularly scary to me because I was a child. So this child's drawing might represent how that child might be feeling when the mom is angry about something else, and the child may interpret it as almost a threat or a danger to them. Definitely something that's scary. So as adults, we may have cues from the environment that seem to come out of nowhere and just trigger fear or emotions or even tension patterns in the body that were never processed. It's like a coping strategy that we learned to work around that time of intense feeling and that nervous system arousal, and that can stay with us if it's one of the programs that our subconscious brain just runs in this unexamined way. Epigenetics can even play a part in how our nervous system functions. So they've shown that in a study with rats, when they had rats that were being shocked on their feet at the same time that they smelled a smell that smelled like cherry blossoms, that the next 2 generations of rats actually produced cortisol when they smelled the substance that was given to the parent rat that smelled like cherry blossoms. So the level of stress that your ancestors were under may even be playing a part in your epigenetics as far as this survival level of your nervous system. Another thing that contributes to our brain and nervous system determining if we're safe or not would be our thoughts about the environment. So you may know that I love memes, and so I picked a few that represent this for me. Me, how's the happiest experience of my life? My brain, nothing. Me, waves at someone who wasn't waving at me. My brain, a core memory, right? Do any of you have experiences like that where your brain really remembers with a lot of emotional intensity something that was embarrassing or shameful or something that was quite small, but for some reason your brain really remembers it? Being employed is cool because instead of anxiety about having a job, you have anxiety about being randomly fired, right? Since our brains are always on the lookout for danger, we could have anxiety no matter where we are. And then this last one, the bird sitting there telling her therapist that her mother used to puke in her mouth. So again, the things that we think about from our past, from the environment, we start to determine if that was okay for us, if that was safe or not, if we have been hurt, and if these things are things we need to avoid in the future. So our autonomic nervous system runs subconsciously because our brain is so efficient and it's always focused on helping us survive. Cues from the environment can trigger fear, emotions, or tension patterns in the body that were never processed. So I put this picture of a dog here, this cute little doggy, because for someone who had an experience with a dog attack, this dog, even a picture of a dog or any dog in the future, might start to cause a nervous system response, even if it's not the same dog or the same type of dog that attacked the person years ago. If that underlying fear is still there, then in this subconscious way, the body may tense up or be triggered into the sympathetic state without the person really logically or rationally deciding they feel that way. And then to bring the discussion of trauma into the picture, basically what trauma is something that's more than our nervous system can handle at that time, and it wasn't processed. So trauma is basically an unresolved autonomic nervous system response. As I said, trauma is this experience that is more than we can handle. So it's subjective. What may be traumatic for one person might not be traumatic to another. Now, there are some general things we call big T trauma that could include abuse, serious injury, or life-threatening experiences that most people would have the same type of traumatic response to. But little T trauma can include hearing bad news, witnessing violence, falling off a bike, bullying or harassment, or medical procedures. So little T traumas, if you think about that graph going up and down, are things that are in those extreme ranges, but we never processed what was going on and what that was about. When a traumatic event is not processed, we may hold onto the memory in our mind and in our body. You'll want to remember with trauma that the primitive brain and the vagus nerve control the nervous system. So reasoning and talking about it and being logical about it with the prefrontal cortex may not be as effective. And for many people, when they start to learn about trauma, they get very worried about the trauma that they may be causing their children or other people that they are interacting with. Or they may want to avoid completely any experiences where they think they might get triggered or have any of those same sensations of the nervous system response. So you can remember that stressful events that are processed, that are met with compassion and understanding and support and love, that will not lead to trauma and that trauma response being activated over and over and over. So you may think of a time where you've had something that was a little bit scary, falling off a bike, but your parent hugged you and told you it would be okay, and you were able to get back on the bike and keep riding and become a proficient bike rider and not have a traumatic experience that you always associate with the sight of bikes or with being on a bike, because you've been able to process through and get to the other side of that stressful situation. So the stress response occurs when the brain and nervous system think there's a threat that you won't be able to handle. And just like the kid in this video, I'll play it again, the nervous system may perceive danger where there isn't actually a physical threat. Now, in this case, the boy might have been causing himself more danger by being in that flailing, thrashing, sympathetic, high fight or flight state. He actually could have maybe potentially caused himself more danger because he wasn't being logical and realizing that all he had to do was just stand up. And the perceived danger was actually a very safe environment. Trauma is more than the nervous system can handle at that time, and it's not processed. Your nervous system response is not an accurate judge of danger. And the more you practice noticing the nervous system states and either down-regulating or up-regulating to learn how to keep that nervous system regulated and healthy and flexible, then you'll build this window of tolerance so that you're less reactionary to the stressors around you in your environment. Now, we're going to talk about interoception, which is a term that just means the way that we interpret our internal state of our body. So we can perceive our heart rate, our breathing, our hunger, our thirst, nausea, itchiness, tiredness, our body temperature, and tension. And it's interesting to know that what they've found in research is that people who have chronic pain are less accurate with their interoception. A lot of times this makes sense because people with chronic pain have either dissociated from their bodies, completely trying not to engage in any of the sensory experience with their body, or they may have a relationship with their body where they amplify all of the signals. So the interoception can be inaccurate either way. When we think about the interoception, again, think about that vagus nerve that brings all of the information from the body up to the primitive brain, the reptilian and the limbic brain. So sometimes you'll be able to think through things and come up with different thoughts and really do a lot of the prefrontal cortex work to understand things differently and to change your results in your life. But other times, you're going to think of this tree and the bottom-up approach, because when we relate to our body first, when we start to tune into what our body is telling us, then we can learn, are we dysregulated right now or not? If we are, we'll want to get into this place where we're more regulated before we start to work on the thought work and that expectation we may have of ourselves to always show up as this thought out, put together, cognitive person that we may want to be. So to summarize again, by tuning into and learning to regulate our nervous system states, our window of tolerance increases. It takes less energy to deal with outside stressors, and it's where we can best use our prefrontal cortex. So I hope this helps you understand your nervous system a little bit better and why it may be harder for you to show up the way you want to in all situations. And in the next module, we'll talk about some specific ways that you can regulate your nervous system back to that window of tolerance or calm state.